next up is Chainlink. And so we have Patrick Collins with us from Chainlink today. He is one of their software engineers and developer advocate. So he's going to take you through using it on Moonbase Alpha.
Awesome. Hey, how's it going, everybody? Thanks so much for having me. I'm going to go ahead and share my screen. So I have 15 minutes, so I got to go crazy fast. I'm going to jump around a little bit here, guys. So we're talking about Chainlink, what it is, how we use it, and let's go in. I have 15 minutes. So in order to really understand Chainlink and how to use it, you definitely have to start with smart contracts, right? Because Chainlink is this tool that takes your smart contracts and really empowers them and elevates them to do even more, right? And so let's talk a little bit really briefly about what Chainlink does, so that we can see why it's so important for the smart contract ecosystem. So blockchains are fantastic and smart contracts are fantastic, but they have this huge issue, right? They cannot connect to external systems, data feeds, APIs, existing payments, or any other off-chain resources on their own, be that computation, data, or what have you. And the reason for this is that blockchains are actually deterministic by nature, right? A group of nodes can very easily say, hey, 1 + 1 is 1. We can all agree on that. We can all reach consensus on that, but they can't really easily agree on a random number because each node is going to have a different random number. They can't really agree on an API call, right? Because one node is going to call the API. The API is probably going to change at some point or get depreciated, get hacked, whatever. And now none of the nodes are going to be able to agree on what the actual state of that API call is, and they're never going to actually be able to reach this consensus. So this is known as the smart contract connectivity problem, or the Oracle problem, in the fact that they can't connect to these external sources. Now, this is obviously a huge blocker because that means we have to stay inside this walled garden, right? We can't interact with the real world, and that's a huge blocker to having these smart contracts be this digitally superior agreements that they need to be. And so what we need here is what's called a blockchain oracle, or an oracle. And an oracle is going to be any device that interacts with the off-chain world to provide external data or computation to smart contracts. And not only do we need an oracle, but we need one step more than just an oracle, right? Because we have all of our on-chain stuff, all of our on-chain logic decentralized and running in a decentralized computational manner, but we have our data coming from a centralized node, or a centralized data source, then our application, in essence, isn't decentralized, right? So we need both our logic layer on-chain and our data layer or external computation layer off-chain to be decentralized. So having a single node is going to be a massive centralized point of failure, and we can't have this. So this is where Chainlink comes in, and Chainlink is the solution. So Chainlink is a decentralized Oracle network that allows you to get data on-chain, send data off-chain, and really allow your smart contracts to have any input and any output, literally limitless. So we'll go into a couple of examples here, but here's kind of a visualization of what that looks like in one of these Oracle networks. So we have this group of off-chain Chainlink nodes. They're all making API calls. They're all responding, getting the data, saying, okay, what's the data? They reach a different type of consensus, and then one transaction, they send it on-chain. Each node is having signed the data, and now we can use that data in our smart contracts because it's coming from a decentralized source. And the pinnacle of this is what's called the Chainlink data feeds. So these are out-of-the-box decentralized data pairs and data and pieces of data that we can just use right from the library, pop it into our smart contracts, and go. So here's an example of ETH/USD. So it is giving the price of Ethereum in USD, and it's coming from this group of Chainlink nodes. So on the right, you can see there's a whole bunch of nodes there. Each one of them is individually making an API call to get the price of Ethereum in USD. It's getting aggregated and then reported on chain so that anybody can just pop in here, say, I want to get the price of ETH/USD, and now they can get it, and it's cheaper than even running your own centralized Oracle. It's faster, it's more decentralized, it's more robust, it's more secure. So we have this incredibly, incredibly powerful decentralized data source for many of the most popular, cryptocurrency pairs or fiat pairs or fiat to cryptocurrency pairs, powering a lot of DeFi. I think it's something like $15 billion in DeFi right now. And not only is having this really robust decentralized data is super important because it's robust and it's decentralized. But we've actually seen a number of protocols take what they think is a proper Oracle solution using a centralized Oracle or some type of inferior Oracle solution and getting hacked and losing literally millions of dollars. So not only is having this better data better, but it's also going to protect you against malicious attackers. And right now, Chainlink is currently, like I said, securing something like $15 billion in the DeFi ecosystem. DeFi, of course, being decentralized finance. Some of the top protocols that are using Chainlink are going to be Synthetics, which makes synthetic assets, securing something like $2.2 billion using Chainlink price feeds. Nexus Mutual, which does derivatives. SEP Protocol, which does commodity money, or kind of like this open sourced pseudo hedge fund type deal. Really cool. Check all these out. And then Aave, of course, securing something like $5 or $6 billion, which I actually think that number is outdated because the space is moving so quickly. But they're all using these protocols to actually get their data into their smart contracts and build some crazy dApps with it, right? So I do want to just briefly show Aave and how Aave is actually using the Chainlink price feeds, these Chainlink data feeds, to actually build their borrowing and lending applications. So if you haven't checked out, so yeah, actually it looks like Aave is currently doing $7 billion, so that number was outdated. As you can see here, you can borrow and lend different assets. We have DAI, USD, USDT, Ethereum, TrueUSD, Aave, Uniswap. And in order for them to understand how much collateral you need to put down to borrow something, if I want to borrow if I want to borrow Uniswap or I want to borrow Yearn.finance, I need to put some other collateral down, right? In order for them to understand how much they need to put down, they need to get the value of the underlying asset and the collateral. So that's how they're using Chainlink feeds on the backside. Ooh, they have dark mode. Oh my gosh, yes, I love dark mode. Well, you learn something new every day. Well, so here's an example of a protocol that's using the Chainlink price feeds, and it understands the deposit APY, the borrow APY, from using these data feeds and using these price feeds. So insanely powerful application. Definitely check it out if you get a chance. And here's the code to actually work with the data feeds in your smart contract. So really what we do is we reach out to the aggregator contract, which is at this address right here. And that address is the one that all the nodes are responding to. And it has that collective decentralized aggregated answer. And we just call, price feed.get latest round data, which is in that get price function below. And that's it. So it's the price feeds aren't on Moonbeam quite yet, but Chainlink nodes can run on Moonbeam. I've tested it myself. It is fantastic. And we will go through a demo in just a minute. I have 5 minutes left. This is going to be the fastest presentation ever. Also, Chainlink VRF. So we were talking a little bit before about random numbers, right? Getting randomness is incredibly important for a ton of reasons, right? Maybe we have a game. Maybe we want to do some type of, random medical trials, or we want to do, some type of machine learning or random, whatever. There's tons of reasons where random applications are needed. However, in traditional blockchains, if you get a random number using like the block hash, or you hash the block hash or something, you're basically giving the miners the keys to your random number in a deterministic system, right? Blockchains are deterministic. So if we say, hey, we're going to make a random number in our deterministic system, it's not really that random. So this is a huge issue, and Chainlink has a solution for this as well, called the Chainlink VRF, or the Chainlink Verifiably Randomness Function. It's a way to get a random number into your smart contracts, and it's a provably random number. So you go off-chain to the Chainlink Oracle, it creates the random number, and then returns it back in a provable manner, which is something that's absolutely insane to me, that you can have a number that's proven to be random. A ton of protocols are using this. Aavegotchis and Ether cards are two big ones. A DeFi one is actually going to be pooled together, which they do this really fun like weekly lottery where the random numbers used for the lottery. But in these two cases, they in Aavegotchis and Ether cards, they use the random numbers to actually create random characteristics for different NFTs, which is an absolute blast. So, and again, this just kind of goes back to the end-to-end, any input, any output of Chainlink into these smart contracts, and they are ultimizably 100% customizable. By being able to make any API call you want, right? You can make any API call. You can group a network of nodes making different API calls at different sources. And you can extend your smart contracts to do literally anything. And if something isn't covered in kind of these core API calls, you can actually customize your nodes even more, building what's called external adapters and external initiators, which we won't be going into here, but we have a ton of documentation on it. I'm going to skip over some of these use cases, but there's an article called 77 Smart Contract Use Cases Enabled by Chainlink. Definitely go check it out if you're looking for some inspiration. There are literally hundreds of protocols that have yet to be built in the DeFi, in the blockchain ecosystem, and a ton of them are just enabled by using Chainlink oracles. So definitely go check that out. Now, if you're looking to learn a little bit more, definitely head over to docs.chain.link. There is everything there, literally, from if you know nothing about Solidity, if you know nothing about smart contracts, you can go to the tutorials, beginners, the basics, go through the video, go through the different sections, and it'll get you up to speed. There are faucets, link token contracts, everything there. The Chainlink YouTube has a ton of tutorials and a ton of workshops that we have a 0 to hero playlist that will send you from 0 to hero. We also have the Chainlink blogs and the developers tab, which will just have tons of different tutorials for you guys to check out. And the Solidity and smart contract starter kits. I personally, whenever I'm starting a new project, and I start projects like literally every other day, I pretty much always start from one of here because they have everything I need to get started with not only a Chainlink project, but just a smart contract project in general. Definitely check out Stack Overflow, check out the documentation, 100% join the Discord. The community is incredibly welcoming and helpful. And again, check out those out of the box examples. So I have 3 minutes left to do a demo. 3 minutes left. So I'm going to go really quick here, but I'm actually going to go to using the using this any API section in the documentation. Because, can you guys see this if I click MetaMask? Oh, you guys can't see it if I click MetaMask. Oh, that's so sad. Well, such is life. But I'm going to use the API because price feeds and VRF isn't on Moonbeam yet. But I'm quite certain that somebody's working on it. But in any case, the any API feature is really kind of this unlimited customizability. So you can get random numbers, you can build your own price feeds, you can do whatever you want with the any API feature, and this does work on Moonbeam. I don't know if, actually, this is a good question. This is market.link. This is a place where you can find oracles. It looks like they don't have a Moonbeam section yet, but if you're looking for a Moonbeam oracle, just reach out to me, just reach out to somebody in the chat. We've set up some Moonbeam oracles in the past, and they work fantastically. So let's actually, I have 1 minute left. So I'm going to really quickly do this demo, showing you guys how to make API calls. I am going to be using the Coven testnet. However, you can absolutely use it on the Moonbeam testnet. I've tested it. It's literally the exact same. All you have to do is change 2 pieces, and I'm gonna tell you where right now. So the way we set it up is we choose our oracle and we choose our job ID, right? And this is kind of how we modularize it. By we can choose a network of oracles. We can choose many different oracles. This is their oracle contract address, and we choose a job ID. The job is going to define. Oh yeah, actually. Oh, Nate just posted in the chat there. The Moonbeam docs. There is an oracle actually right from the Moonbeam docs. And it has all the code and everything that you need in there, which is absolutely fantastic. So, oh yeah, your guys' docs are amazing. Yeah, the Moonbeam docs are amazing. So you can absolutely do this on the Moonbeam docs as well. But what we're going to do is we're going to be calling this API call right here. I actually might be at my limit, so they might kick me out. Yeah, I'm over my limit, but it's going to return something that looks like this: raw FUSD volume 24-hour, and we're going to be looking for this volume 24-hour. So we add this API call to the job. We set the path, so we walk down this JSON response to get this volume 24-hour. We multiply the number, and then we send the Chainlink request. And in a second fulfillment function, we're actually just going to set the volume that is returned to this volume variable right here. And I'm going super, super fast. So we're gonna move to injected Web3. We're gonna deploy this contract. MetaMask pops up, but you guys can't see it because it's not letting me share that. And we're actually gonna deploy this to the Coven testnet. Again, you can follow the Moonbeam documentation there, which does the exact same thing, but on the Moonbeam alpha. And Now that I've deployed this contract, I'm going to send it some link. I'm doing this in my MetaMask right now. I apologize, you guys can't see this, but I'm sending this contract some link. Here's my transaction hash. And once the link is sent, I can actually call this request volume data. And if we check the volume now, if my internet decides it wants to work, there we go. The volume will be 0. Now I'm going to go ahead and request volume data. My internet's being crazy slow right now. Sorry. I'm going to confirm. Since it's funded with Link, it's actually going to make the request to the Chainlink Oracle in one transaction. And then in a second transaction, the Chainlink Oracle is actually going to call this fulfill function, return it, and update this volume data here. So in this transaction, we've actually we've called the Chainlink Oracle by sending the Chainlink request to the Oracle, and then we're actually going to get it back in this fulfill function. Yeah, the Moonbeam docs are really fantastic, and the Moonbeam team has done a fantastic job actually with all their developer experience. So you know, like I love talking about developer experience. You know, Moonbeam team, massive thumbs up from me on developer experience. But now if we hit the volume number, if my internet wants to work, maybe I have to reset the internet after this. We can see we get a response here. And then the question is, oh, why is it so big? Well, Solidity doesn't work with decimals so well, so it's actually multiplied by 10 to the 18th. So it's going to be 18 zeros. And I am over time by 2 minutes. I am so sorry, Nate.
It's all right, man. Don't worry about it. Well, thank you. Thanks for the presentation. Good work. And again, all the documentation is live on using Chainlink on Moonbase Alpha. So feel free to check that out. So next up is going to be ChainSafe. So thanks again, Patrick.